Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's very hard other type of puzzle. And it's not a Sudoku, so keep that in mind. Um, it's also very hard, as rated by the Logic Masters Germany forum, and I believe them. All the very hard puzzles I've done, the easiest one I think it was basically challenging level. So, and this is a different type of puzzle, but most of the time people try it out, and the ones who can do it usually rate it correctly. But the puzzle is called Crate Cave by KNI. And here are the rules. We have to shade some cells such that all unshaded cells, all unshaded cells are orthogonally connected, and all orthogonally connected groups of shaded cells touch the edge of the grid. Clued cells cannot be shaded. So all the numbered cells that we have are not shaded. So this is typical cave shading rules where all the unshaded cells are orthogonally connected. So then what does it mean to be orthogonally connected? It means you can go from any unshaded cell to any other unshaded cell just by going through edges while staying within the unshaded cell region. This is too big of a grid to basically give a good example, but something like this could work. Something like this would not work because this cell, to get to the other unshaded cells, would have to be able to would have to go through a corner or would go through an edge but go outside of the unshaded cell region. So that is how caves work. Also, again, all shaded cells that are orthogonally connected must touch the edge of a grid in one of the cells. So keep that in mind. Additionally, crates may be placed in some unclued, unshaded cells. So that means anything that's not shaded and that doesn't have a clue in it can have a crate placed in it, which is why this is the crate part of the crate cave, such that no crate shares an edge with either a shaded cell or another crate. So these crates cannot share an edge with another shaded cell or with another crate. And crates block connectivity of unshaded cells. Does that mean that it also blocks the orthogonally connectivity of unshaded cells? Let's take a look at the example, actually. It looks like it does. Because, yeah, it looks like it does. So, so basically, unshaded cells must be all orthogonally connected, and that includes cells that are shaded and through crates. So crates block that orthogonal connectivity, and so do shaded cells. Now, a clued cell has one of two meanings, so it could be either of these meanings. Either first, it's the total count of unshaded cells seen in all four directions, including itself, where shaded cells, crates, and the edge of the grid obstruct vision. So obviously this could work if we had, say, a crate here. What do we mark the crates? I guess we'll mark the crates as red. As long as these would be shaded, I guess. So then this would be valid if we did something like that. Also, So that's one of the two meanings that the clued cells can give us. So if this was blue also, then this would work. And that's directions in the horizontal and vertical directions. So it's the total count of unshaded cells seen in the four directions where shaded cells, crates, and the edge of the grid obstruct vision. Or it's 2, the total number of crates in the same row or column as the clue cell. And no two orthogonally adjacent clues may both be of this type. So in other words, you couldn't have these two clues be basically talking about the total number of crates for both of them. You could have one of them being saying is signaling a crate here, but that goes for any orthogonally adjacent clues given. And orthogonally adjacent clues are basically cells that share an edge with each other. But they basically, this would basically, so say this was counting crates. That would mean in the row and the column, there would have to be 3 crates combined. And I looked it up beforehand, but let's just check the example that they give. So this is marked as a 2, and that's saying that, or this is basically saying 2 is how many cells it sees. This is saying 2 is the number of crates. This is saying 3 is the number of crates in that row and column combined. 2 is the number of crates in this row and column combined. So basically, that is one possibility. And if you have 2 adjacent clues to each other, 2 cells, 2 clues sharing an edge with each other, at least one of them has to be counting the number of unshaded cells that are seen in all 4 directions, including itself. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, 0 can never be the amount of unshaded cells it sees because every clue in this grid is unshaded. So we know then that this must be counting the number of barrels in the row and column that it sees. So this cannot, there are no barrels anywhere in this rows and column. So we'll mark it as yellow. Blue, I'd like to have basically set aside for the shaded cells. Red, I'd like to set aside for barrels. One of these could be, so these, if they were both counting unshaded cells seen, cannot work. Because if they're both 2, because then they would be connecting to each other, but not to any other unshaded cells. And remember, the unshaded cells have to form some set of orthogonally connected, it has to be one region of orthogonally connected cells. So that means one of them must be counting barrels in the row and the column. And the other one must, since you can't have 2 cells that share an edge be of that type, the other one must be counting the number of shaded cells, the number of unshaded cells seen in the 4 directions. So it can only see the other unshaded cell here, which means this is going to be blocking vision. But we don't know if it's shaded or if it's a barrel. Or both of them could be barrels, right? We know these cannot be barrels. So there must be some shading going on here. And one of these is going to have to be blocked. Um, Same with this, but this could be barrels. So one of these is shaded, definitely. We don't know which. Um, we have something kind of similar here, but the thing is we don't have 2 and 2. Can you ever have 13 barrels? Um, in a row or a column. What is this? This is 7. This is 14 by 14. Can you ever have 13 barrels? Obviously, every other one. Um, so say we had barrel here, barrel here, barrel here. So that's 1, 2, 3, 4, 5, 6, 7 in that direction. And then 7 in the other direction seems feasible. This is either 2 barrels here or 4 in a certain direction. This is definitely counting barrels here. So the barrel one, I think they put the circle around. No, the barrel one is the normal one. The circle is around the one that's not. So let's make orange the barrel counting one. So we know that's a barrel counting one. One of these has to be a barrel counting one. And the other one is the number of unshaded cells. Um, One of these is shaded or blocked, at least. These could be both counting unshaded cells. We don't really know. Um, Same with this. The most barrels you can have in a row is 7 or column. Um, these could technically be counting the number of cells they see. So what happens if that's the case? Then we know this is surrounded, this is blocked, this is blocked. And it must go, it could go 1, 1 here, and then this is blocked. And that's blocked. That is possible. So remember, the shaded cells could be touching themselves. The crates cannot be touching the shaded cells or the... so that's possible here. Um, hmm. Hmm. Yeah, this is definitely part of the break-in, but I don't know how much that tells us. What happens if these are saying how many cells they see? 0 obviously is the number of barrels because you can't have cells counting unshaded cells and not count themselves, obviously, because they would be unshaded, because all clues are unshaded cells. Um, hmm. Uh, can this be 2 as shaded, unshaded cells seen? Well, oh, interesting. The answer is no. If this, well, that's not true. Never mind, never mind. I'm thinking. I was thinking that these are not shaded cells, but it's basically not barrels. So you could have shaded cell there, shaded cell there. That could certainly work. Shaded cell there, shaded cell there. Wait, that doesn't work. Oh, that's an interesting aspect. For 2 diagonals, which you have unshaded cells, if you have the other diagonal be the other shading, whether it's the barrels or whatever. Oh, it can't if it's not barrels. So say this was actually shaded. Then this doesn't work because the shading must get to the edge here. This shading must get to the edge somewhere here. And then the diagonal cannot be the 2 cells on the diagonal can never orthogonally connect. But if one is barrel, then that could work. Interesting. So this could be red and red here. That is possible. Um, one interesting aspect of this 13 and the 12. Um, where are the barrels potentially here? So 12 this way. Could have barrel here, barrel here, barrel here, barrel here, and barrel here. That's 1, 2, 3, 4, and 5. And you could still have 7 in this direction. That's very unlikely, but it's possible, right? So if you were to have that, it would be something like this. Hmm. These two are not guaranteed. This one's not guaranteed. But these would have to be guaranteed. So if this is barrel, this would have to see 13 cells, which is not going to work. Would it work? There's 13 here, therefore this is shaded. 1, 2, it would see that. Not necessarily, so this would see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is not guaranteed, but it has to orthogonally connect. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 4, 5, 6, 7, 8, 9, 10, 11. And then we have 2 more. So this would be 2 would be number of barrels. 2 would be direction seen. So this cannot be blue. This would have to orthogonally connect out to the grid. So then this would have to be blue. This would have to be barrel. So then this would be green. This would have to be green. So all of these would be green. Okay, well, there's that too. This would, well, we don't know which one of these. So this one, so we definitely have 1 here in one of these 2 cells. We have 2 here in some of those cells, but we don't know which ones of those are valid. This is shading. This has to be barrel because we need 5 barrels here. This would then be unshaded. 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 Okay, so this would definitely be that case there. One of these is barrel. We're not sure which. This must see 13. It sees 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, and this must have 2 barrels here because this sees more than 2 unshaded cells. So then in that case, the barrels would have to be here and here. And since it sees 13, it would have to be green here, green here. You'd have barrel here, barrel here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This must have a barrel here, so this is barrel here. This is green. This must be blue. So this is 2 barrels here. This is green to orthogonally connect. This is orthogonally connecting. This then says this cannot match. This can match the number of edges seen. So 3, that's fine. 7 must match barrels because it can't see 7 unshaded cells. So then this would be barrel. This would be barrel. So this is assuming that this is barrel here. This is not 4 barrels, so this must see only 4 cells. It cannot, it could connect to here. This could see 2. So it already sees 1, 2. We don't know if that's a barrel or not. This has to be a barrel. So this is a barrel, which means this cannot be barrel. So this must be barrel, barrel here. This is green. Then these are green. we have 5 barrels here. So one of these could count barrels. This shaded, though, has to get out. So therefore, this must be shaded here. And it must get to connect to the edge. It cannot go here. That's green. It must connect to an edge here, then. So these are blocked. So this sees 1, 2, 3, 4 at most. So this must be barrels also. Which means this must see direction. So that's 1, 2. 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9 at the least. So these are all green in that instance. This must be blue here. Must be blue here. It has to connect to an edge here. So these are all blue. This might actually be the solution. That's interestingly enough. This is barrels. So it sees 5 in this row. So it must see 1 in this column. This sees 9. So it sees 1, 2, 3, 4, 5, 6, 7, 8. And then one of these. This must go through here. Interesting. You could have blue there. Green. Okay, so this is 2. Oh, we don't have to have a guaranteed barrel here. You could have one. Okay. Okay, so this is not necessarily the case. Right, this could be shaded cells. Okay. Huh. So we're not guaranteed that these, Okay. Let's try 13 and see what happens there. If they are barrels. So 13 would require... How many here? One of these two. One of these could to be 2 out of those 3. So 1, 3 are guaranteed. 4, 5, and 6. So this would also have to be 7. So you have to have 7 this direction. Which would make this green, 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 green here, and green here. And this is one of these. It has to have 2 here. And then this would be 1 here, 1 here, and 1 here. 1 here. This must see 12. So it sees 1, 2, 3, 4 at least, 5, 6, 7, 8, 9, 10, 11, 12 at least. So it would have to be all of these are green, if that's the case. Okay. So then this is blue. It could very easily get out. Oh, this could go blue, blue, and that would be perfectly fine. This is barrel, though, definitely. So this has to be blue, green here. One of these is barrel, one of these is barrel, one of these is barrel. This sees more than 6, so this must be barrel. This sees barrel. So it's 2 total here. Interesting. This is 6 total. This then has to see 9 cells, but that's not possible. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 already. And then we have to, this cell has to see more. So this doesn't work as crate counting. It must be counting the number of unshaded cells it sees. Interesting. So that's why that doesn't work, because this 9 contradicts the 12 that's seen. The question is, what happens if both of these are counting the unshaded cells? If they're both counting unshaded cells, that's going to be problematic. One of them has to be blocked. So if they're both counting shading cells, unshaded cells, they're going to be blocked. One of them has to be blocked. Therefore, it must continue going up this way. Either way. So if you have 12, this is going to, one of them is going to be blocked. Say it's this one. We see 5 here, 6, 7 at most, 8, 9, 10, 11. But then this 4, how would this work? Okay, so 12 here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This could not be 4 unshaded cells seen only, so it must have 4 in barrels that it sees, but it sees 0 here. It must see 4 here, which is not possible because of the number of shaded cells this has to be, which means the 13 is counting the number of barrels, because we can't have both of these counting unshaded cells. Because one of them is going to be blocked by the 2 here. So that means you have 5 at most. Because one of these is counting the number of unshaded cells they see, which means one of these is going to be blocked. One of these is going to be blocked. So therefore, if we try going 5 here, this has to see 9 more in this direction. And therefore, this is going to be part of it, which means it's not going to see 4 cells only. It has to see 4 barrels, but it can't see 4 barrels because this has to see at least 8 other cells here. So, therefore, one of these has to be counting barrels, and it must be the 12, because we tried the 13, that forces the 12 and the 9 to see the same cells, but the 12 only sees 1 cell more outside. So therefore, 12 must be barrels. And it must count 7 this way. Yeah, that's the reason why I was like suspect of that, because it's felt very like the solution path. This is 1, 2, 3, 4, 5, 6, 7 barrels. We have 1 here, 2, 3 here. And then we have 1 of these and 1 of these. So that's 5 barrels here, 7 barrels here. That means we have to have this go. These are unshaded because the barrels cannot share an edge with shaded cells or other barrels. We're going to mark the ones that the blockages we know with pink, so that it's not, we don't get confused with the barrels being red. So one of these is going to be red. 13 sees the orange, And then it must see again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So these are all green. This counts actual scene. This must be barrel then. So this is shaded and cannot be barrel. That means it cannot go out here. This is definitely green. So this must be shaded also. This can't be a barrel then, so it must be shaded. This has to go out, so it goes out there. This cannot see more than, it sees 3 at most here, and then 2 more here. So cannot see 6 cells, so this must be counting number of barrels. So there's 1 more barrel in this column. If we try to have this be blocked, the problem is we know there's a barrel here, and this cannot orthogonally... So if this was shaded or a barrel, the problem with that is we know we have another barrel here. So if this is blocked, that means this would be barrel. If this is shaded, that means this would be barrel. And then this cannot orthogonally connect to the other unshaded cells. So this must be unshaded. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. One of these is blocked. One of this could be unblocked. So this sees... Can this see 3 cells? It could, actually. Can this be 7 cells? That could also work. So if it's 7, these would all be green. And this would be red. That would be the barrel there. And this would have to count number of barrels. Because it sees more... Well, 1, 2, 3, 4, 5, 6... Oh, this can't see 7. Because it would necessarily have to see 8 if it does there. So this cannot see 7. This must be counting number of barrels. Which means this is then... so it can't see 7 because it's blocked here. That's a barrel. It would have to be either 6 or less or 8 that it sees. It can never see 7 exactly. So that's why this is barrels. This sees 3, so this must be blocked here, which means that's a barrel. So that's green there. You could have a blue there or a red. We don't know. We don't know about that. It could go that way, it could go that way. This counts number of barrels. This then has to count directions, and it can go at most 2 that way. So 2, 3, 4, 5, 6, 7, 8, 9 at least. So then we know these are all green. Blue has to get out this way because it has to get to an edge. This is green. I guess we should have the yellow there, so that signifies you can't have a barrel there. Well, no, green we know is necessarily unshaded. So it has to go here. This could go 4 in length. It cannot be number of barrels. So this has to be 4 in length. So it could be 4 that way. We know it's either 4 here, 4... It cannot be 4 here. So it's either 4 here, or it's 4 here. Which means this is always green. Because this is more than 4 barrels there. This has 1 barrel here at most. Or it actually has to have exactly 1 barrel. Can this ever add to 6? Or C6? No. It would see 1, 2, 3, 4, 5 at most. So this has to be barrel. So that's 6 barrels there. This could be barrel there. We don't know. Could this see 4 cells? Yes. You could have block, 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 block. Can this see 7? Yes. This has 7 barrels here. It cannot be barrel, barrel there. But you could have 3 there. You could have a decent amount here. So this sees 1, 2, 3... Oh, wait. This is not necessarily green. 1, 2, 3, 4, 5, 6... No. 1, 2, 3, 4, 5, 6, 7, 8, and 9 at most. So it does go to here, which means this does block this. Blue has to orthogonally connect to the edge of the grid. So it's going to go through that way. Can this be 2 as non-barrels? Maybe. That means all of this would have to be blue. So you'd have blue here, blue here. This could be barrel. But that, okay, that doesn't work. So this cannot be, because this is required to be green. This then must count barrels. So this counts barrels also. Because if we try to have 2 here, the 6 would be blocked from being orthogonally connected to the rest of the unshaded cells. So this counts barrels too. So we have 1 here. That means 1 more barrel along this path, which makes sense because we have blue going somewhere along this path anyways. So... We have 2 barrels, then... This is 2 at most, which means this has to be at least 4 barrels here. That's interesting. This counts 5 barrels here. Geesh. How do we know that this is solved? That's another question. Does it have anything about answers? No. This has 1 barrel at most in this column. Or it has to have exactly 1 barrel in this column. This has to have at least 4 barrels in this column, in this row. We don't know how to divide up here. Hmm. Oh, no. I was gonna say, we have the possibility for 5 barrels here. But we don't know how many we have in this column. This is connected. C's 13, 9, 4. Hmm. This C's 4. There are 2 barrels total here. So if this is 4 that way, this has to be blue. That's interesting. So let's see what happens if that's the case. This is then blue. This has to connect to the edge of the grid. This green has to, well, we could technically, this is going to basically have to combine, which means this must go out this way to orthogonally connect. That seems fine. This is 4. This cannot be shaded. So we then know this can't be barrel. Sorry, it could be shaded, can't be barrel. So because of that, we have 1, 2, 3, 4 barrels, definitely, which means that we must have 2 here. Which means then this would not have barrels. So this would have to be barrel. One of these two and one of these two would be barrel. So this could not be barrel here, but it could be blue. These would not be barrel. This seems fine. That sees 4. The blue does not have to stay here. It could go something like that. So we could still have a barrel in one of these. We cannot have a barrel in any of these. This obviously can't be barrel. These can't be barrel because it has to pass through here as blue. This can't be barrel. It would block a blue. I guess this could no, this can't be barrel. This is boundary. But it could be blue. But this can't be barrel. So then barrel has to, well, not necessarily. Yes, necessarily. So this yellow stuff also is the same for here, right? There's only one barrel. This can't be barrel because it's next to, this is blocking this. So this is either a barrel or shaded. None of these can be barrels. This could be barrel. This can't be barrel though. Obviously it's not, it's next to a shaded cell. And this has to get out somewhere here. So none of these can be barrels, right? If it goes here, then this blocks all shaded cells from being here. And then blue can never connect to the edge of the region. But barrel could be here or here. Right? Because the shaded cells could get could do something like that. Okay. Yeah, that still doesn't help us too much. Um, hmm. What happens if we have this as the unshaded region? Then this would be shaded. These would have to be shaded because there's no barrels there. This has to orthogonally connect. Um, that seems fine. This can't be barrel because it's next to a shaded cell. This has 3 barrels at most. You could have a lot of barrels there. That's interesting. That doesn't really restrict anything either. Hmm. Okay, not too helpful there. What else do we have? Um. This could be counting barrels. That could be 3. Hmm. This already sees 4. Can it be full blocked? Maybe. That means this must orthogonally connect. So we have to orthogonally connect this way. This must orthogonally connect. This could be blue going that way. That is certainly possible. Hmm. That seems okay. This we'll see. Hmm. You don't have to orthogonally connect through here. You could orthogonally connect through here. Doesn't seem to lead to as many restrictions as I would like. Hmm. Can these... So if these are both non-crates, then this sees 7, so it would have to see those 6. And then this, and this would see 6. So then this would be blocked here. So we're saying if both of these are not talking about crates. So this would be something there. This would have to be a crate because it doesn't orthogonally connect to the edge of the grid. That seems okay. You have probably crate here. You have 1, 2, 3, 4 still possible there as crates, and that's still fine. So then this could be 1, 2, 3, 4. Yeah, this is a lot. This could be a crate. So we just know it would be blocked there. That seems fine. One of these at least must count the number of unshaded cells. The other could count crates. Or it could be a number of unshaded cells. So say they both counted number of unshaded cells. We know then this would be blocked this way. This would be blocked here. So it must go either this way or this way in that case. That doesn't help us much. Hmm. Hmm. Obviously, this can't be crate. But it could be blue. Um. ugh, um. Um. Hmm. We know both of these cannot be crates. Or, I mean, both of them could be crates. Sorry. You can't have both of them not be crates, I should say. Well, no, that's not true. One of them has to be a crate, I should say. That's probably a better way of putting it. Because there's two at most here. If you have both of these being crates, that means there's 0 in this column. And this can't have 6 crates here. 1, 2, 3, 4, 5 at most. Um... hmm. Um... Can this be the number of crates? Probably no, right? That means there's 2 here. There must be 5 in this direction. I mean, technically it's possible. Oh, one thing we know. One of these 2 must count the number of unshaded. Well, it could see that way. Ugh. So there is no guarantee it has to go this way. It could see 6 cells going that way. That's why you can't. Yeah, you don't have anything here. If this is crates, that means there are 3 crates in the row. Other than that, we don't really have very much. How else could this go? So obviously we could look at those, we could look at that. This one seems not really that restrictive. This one's kind of restricted, so we could look at that. Any of these? Not really. We could potentially look there, there maybe, there maybe. Hmm. Oh, this has to orthogonally connect. So this must be green. Because this is unshaded cell. So this cannot be 4 this way. It must be 4 that way. So then this is green. This has to be, cannot be a crate, so that's blue. It has to orthogonally connect to the edge. So that goes this way. This is going to be blocked from the other greens. So this cannot be yellow. No yellow, no unshaded cells, no crates there. This has to orthogonally connect to the rest of the unshaded cells, so this is unshaded. So this sees 4. Okay, that's good. Blue has to orthogonally connect to these. It could go this way. Okay, so one of these has to be a crate. We don't know which. This could be a crate, so the blue could go all the way to here. So the blue is going to have to cross back here. That's definitely certain. These cannot be crates. So we have 1, 2, 3, 4. So we have to have 2 crates here, which means there cannot be crates here. So this is a crate. One of these 2 is a crate, one of these 2 is a crate. And then the remaining 2 have to be in this column. we could potentially have 2 crates there if the blue goes out this way. Is that really valid? I don't think so, actually. So say we had crate here, and then this would be the crate remaining in this column. The problem with that is the blue has to get out. And oh, they could orthogonally connect this way. So that could work. Can you have crate here? Maybe. You could go something funky like this. And then you have crate there. Can you have crate there? No. So if you had crate here, that means all of these are green. Blue would have to go this way. Or this way. But then that would force... Yeah. Blue would be either here or here. But the problem is then this would have to be red, and that would force green to be here. The blue would never actually reach the edge of the grid. So this can't be red, but it could be red here, it could be red here, and it could thread the needle by going there. That is possible. Interesting. There's only one here. There could be 1 or 2 here. This could be a barrel. So this is barrel here. Or crates, I guess. I keep saying barrels. I don't know why I suddenly thought of these as barrels. You know what I meant. If I was basically saying barrels is basically the same as crates. This sees 4. What happens if this is counting the number of unshaded cells? So then this is obviously shaded or barrel, shaded or barrel, shaded or barrel, shaded or, sorry, crate. Shaded or crate. You would have to orthogonally connect to there. You would have to orthogonally connect to there. And there. And there. This can't be barrel either. If this is no barrel, you could go blue going that way. That is possible. Never mind. Actually, yeah, so this can't be barrel. If that's barrel, this is all green. Blue does not orthogonally connect to the rest of the grid. Same with this. All of these cannot be barrel. But you could connect this way, so these could be barrels here. Okay. Hmm. Um, barrel here, barrel here. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this can never be the part that's seen in the 13. But what else could it be? Let's continue with this, I guess. So then this has to unshaded connect this way. This must orthogonally connect that way. This must be orthogonally connecting that way. Because we have a barrel there. If the blue connects to here and here. So if blue goes to here, that's going to block. It has to exit out. That means this green is never going to be connected to as a region. So this has to be a barrel. Which means this is green. So this blue has to go this way. That's definitely blue going that way. Green has to orthogonally connect. Blue is going to block this. So green has to orthogonally connect this way. This is kind of looking like a solution, though. Blue goes this way. It could be part of this. This must orthogonally connect to the green here. So far, that seems fine. This has to be barrel because it can't reach the edge. This is blue. This must orthogonally connect to the rest of the green, to the rest of the unshaded. This is 1, 2, 3 shaded crates at most, which means there must be 4 in this row. Seems fine. If this were blue, that would block this off from connecting to the rest of the unshaded cells. So this must be a barrel, which means this is green. This could be blue here. That seems fine. This will be blocked by the green unless this is going green there. This is actually looking like a solution. I was hoping it would lead to a quick contradiction, but we don't seem to be having that. Mm. Let's say this was counting barrels. So therefore, there's 2 barrels this way. There's 5 barrels this way then. So we have barrel here, barrel here. Barrel, barrel, barrel. So then this is all green. This cannot be counting the unshaded cells it sees. So this would be barrel, which means this counts this unshaded cells it sees, which would be 5 that way. This must orthogonally connect. This must orthogonally connect. This must orthogonally connect. This must orthogonally connect. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is block then. This is orthogonally connected. This is barrels. This could still count the number of barrels. 5 works. Or it could be 5 here. That also works. This counts 6. This is done here. This sees more than 4, so this must be counting barrels. Okay. If this is blue, that means none of these can be barrels. So then we would not have 2 barrels in this column, which we need to. So this must be barrel, which means this is green. Hmm. We just have 2 here. 1 here, 1 here. This is at most 3 barrels here, so we need 1 barrel at least here. That means there's 2 barrels here. We have 1 there. We need another barrel. There's 1 barrel here, and there's no barrels here. So since this doesn't have barrels here, this doesn't have barrels here, and it must see 4 cells. Interesting. I mean, that seems fine. This has to be shade. Okay. That means this can't be barrel. No barrel here. Ah, and then these are both not barrels, and this doesn't have 12 barrels. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. So that would fail. So, This can't count barrels. So this must count something. It counts 2 in a direction. So it either goes 2 that way, which means it would go here. So it cannot go 2 this way. It must go 2 this way. So this has to go 2 this way, which means this is blocked there. This is blocked. It must connect to here to be orthogonally connected. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Therefore, this is blocked here. It's blue. So the green has to orthogonally connect there. This is blue, so that's fine. So this is done. Yay. That means barrel-wise, where are the possible barrels? We have 1, 2, 3 here, 4, 5, 6, 7. So we don't have anything restricted there. This is definitely 2 going that way. That was pretty convoluted. Anyways, we have 1 blocking here, 1 here. We don't know where. Oh, this can't be barrel. So we have to have barrel here and barrel here, which means these are all green. This must orthogonally connect, so it must go that way. This sees then 1, 2, 3, 4, 5, 6, 7, 8 at most, so it must go green there. This could be blue, it could be barrel, we don't know. This sees 5 barrels. We have 1 here. Can we use this now? This could still be 5 barrels that it sees. Can this be non-barrels? I guess, if this is 6 that way. Right, it would be 5 that way if that's the case. Say this mapped correctly. So we have number of unshaded cells, that's 7. Therefore, this would be blocked here. This is at most 2, which means this would have to be at least 5. So barrel, 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 and then one of these 2 is barrel. I mean, it's possible. And this would then be forced to be barrel if that's the case. 1, 2, 3, 4, 5, 6. So this could still count barrels there. We don't know. That seems fine. One of these would be crates. This would have barrel here. We'd have 1 here. We'd have 1 here. That seems fine. This could still count crates, so that would be fine. Well, that's not quick, so let's not go down that path. Let's orthogonally connect. Can this be 4 barrels? 1, 2, 3, 4. Yes. So if there are 4 barrels, then it's 1, 2, 3, 4. If it's 4 as an area, it has to be 4 at most there. So it'd be one of these is definitely blocked. We don't know which. So you could have something like that. Well, we know we have a barrel here and we have a barrel here. So if this is 4 that it sees unshaded cells, we have to have shaded cells here, but it would have to go through one of these barrels, and that's not allowed. So this must be seeing number of barrels. So we have 4 here. Obviously none here. This can never have shaded cells. Because if we have shaded cells here, it would have to go up and they would go through, it would go next to a crate. Sorry, I keep saying barrels. I don't know why. I just got into my mind that these things were barrels instead of, but they're crates or whatever. So this has to be unshaded. You could have a crate there. That's fine. There are 4 crates along this path. So if this is crate, that's crate. One of these is crate, one of these is crate. So this is 4 crates here. This could be 3 and 4 as crates. That could work. Crate, 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 which means shading cannot go to here. Interesting. Hmm. And the reason why these are all green, again, there are no crates here, right? So there's no crates here. You can't have shading here because it must go through a barrel in one of these 2 cells, or two in these 4 cells. Can this see only 4 cells? If it does, it can't be this way. It has to, so if it sees 4 cells, it would be like that. And then how would that, so this would be blocked, blocked. That seems possible. Hmm. Two. Can this see 3 cells? Maybe. Otherwise, it has 4 crates here. Which means that sees 1 this way because it has only 1 from this. And then it has 3 this way. Well, you could have crate, crate, No, you can't have both of these be crates. Which would mean crates here, and then one of these would be crate. It certainly seems feasible. Okay, so this, again, this has to be green. 1, 2, 3, 4, 5, 6, 7, 8, and then this is green. Okay. That doesn't help us anything, though. Oh, how would the crates work here, then? Again, you can't have both of these be crates because then this would be blocked from orthogonally connecting to the rest of the unshaded cells. These can't be crates because they're next to blue shaded cells. We have to have then a crate here. One of these is a crate, and then one of these is crate. Since this is a crate here, this cannot be crate, which means this must be crate here, and this must be crate here to give you the 4. So these are unshaded, which means this is crate here. So either way, if this is counting crates, it has to have 4 here, and only one of them could be here, so that must be blocked. Otherwise, this sees 4 cells that are unshaded, so cannot go here. It sees already 1 here, so it has to be these 4. It can't be 5 here. So this is, either way, this is definitely going to be blocked. So if this sees 4 crates here, then this is not seeing crates because we have 3 crates here and 1 crate here. So again, one of these is blocked. This would be blocked. This would be crate. So then this would be, these would be green. This would have, not red, green. These would have to be red to count, to give you 4 crates in this row because we have 2 crates in this column. That looks fine. This is green. So then we have red, green, red, green, red. So that would be the 4 crates in column 7. This has to orthogonally connect as green. So this would see more than 2 cells. So this would have to be crates, which means this has to see exactly 4 cells that are unshaded. So these would be blocked. Okay, this would see 2. It has to orthogonally connect, and then this would not work. So this cannot see crates. That's kind of convoluted to do that. Anyways, this sees 4 cells. It must go this way. So then this is green. This is blocked. This could be crate. It could be shaded. We don't know. Same with this. This cannot be crate then. So these can't be crates. This is not crate, which means crate has to be there. One of these could still be crates though, so this can't be crate there. It could be shaded there though. One of these is crates. One of these is crates. So can you ever have crates here and here? I mean, it's possible. Okay. Can this be the number of unshaded cells seen? That would mean these are both pink. This would have to be pink. So this would have to be blue here. These would then be blue. And then this 5 is stuck because we have that diagonal thing again, like I was talking about. So this cannot be number of unshaded cells seen. So this must be crates. So it sees 0 here. It must see 3 here. So one of these 3, and this, or 2 out of these 3. It would have to be here then, and one of these 2. Okay. We cannot have, well, this could be counting crates. If we had, crate here, then that has to be 2, right? So either this is crate, or we have crate here. That means if we have crate here, this must be counting number of crates. So this must count the actual number of cells it sees. We have 1 here. You could have up to 1 here, up to 1 here. So these would both be green in this case. That's fine. This must connect to this here, because the blue is going to block it out from connecting anywhere else. Or it could connect to here, I guess, if there's a crate there. Can this count? This cannot count the number of crates. We have 2 crates in the column and 1 crate in the row. So this must be seeing only 2 cells, 2 unshaded cells. So this could be crate, it could be number of unshaded cells. So these are all unshaded. Or sorry, not unshaded. These are all non-unshaded. But they could be crates. Interesting. Seven crates. This is blocked here and here. That's interesting. Can this see 7 cells? So, oops. We don't know that. This is definitely 2, though. Okay. So we have 1, 2, 3. Okay. This cannot be crate. These can't be crates. Which means We have one here, and this must be 2 here. So this is crate here, and this is crate here. Which means this has to be... These are green. This green must connect out orthogonally. It has to orthogonally connect. This can't get to a shade to the edge, so this must be crate, which makes this green. So this is that means this is crate and crate here, which means these cannot be crates. So this does see more than 2, so this must see crates, and it sees 2 crates here, which means this cannot be crate. It has to be blue. That must orthogonally connect out to the edge. So this is blue. That means it must get through here. So these are all blue. Connects to one of these two. I'm not sure which. These cannot be crates. No more crates here. No crates here. No crates here. This is not going to orthogonally connect. Shoot. That is a fail. Huh. Yeah. How do I... Oh, I can go through this way. I have to go through this way. This blue has to orthogonally connect to the edge of the grid. So then we have to go this way. Goes through one of these. This is going to be blocked from here, so this must orthogonally connect that way. So this sees 2. We have to orthogonally connect here. This must orthogonally connect there. Can this be a full 7 going that way? The answer is no. Well, no. Yeah, the answer is no. Because the blue has to orthogonally connect to the edge, and one of these 3 is... So this has to be number of barrels. So we have 4 here. We must have 3 going this way. We have to orthogonally connect to the green region, so that's orthogonally connected. Because it has to go through this way. This could be barrel here. So right now... this can potentially orthogonally connect this way. So blue's either going this way or it's going this way. We don't know which. This is green, so this has to connect there as blue. This sees 2 cells. This could still count 4 barrels in the row and column. Okay. This has 3 barrels. And none of these can be barrels anymore, so this must be a barrel here. Okay. This counts 2 barrels, so this must be C5 cells. Which means this goes to blue here. This... don't have any information there. This has only 2 barrels at most here. And it can only have it cannot have 3 barrels here. So this is seeing number of cells. Well, it's blocked here. It's blocked here. It cannot go all the way to here. So this has to be green. It can only go up to here. So this is guaranteed to be green. It could go green there. Okay, so because this is green, blue has to go this way. So this cannot be barrel there, which means one of those two is barrel. Or crate. I keep saying barrel. I don't know why I say barrel now. It's crate. That means it must go through this area, so that's blue. We have 1 barrel crate left in this column. This has to orthogonally connect to here. So one of these is clear. If this went blue here, this would have to be at least green there. So the blue would have to go there. Which means one of these two would have to be a crate. Because we need a crate in one of these two. At least. If this is green going this way, blue going here, the problem is blue has to get through here. One of these is crate, one of these is crate, and either way it would be sharing edge with the blue. So this cannot go this way. This has to be then green. So then the blue has to go out this way. You cannot have 4 here because then this must be counting the number of crates. So it cannot be, because this would be blue, this would be blue, but then this would be blocked off from connecting to the rest of the greens because the blue would cut this across here. So this must be counting number of crates. We have 5 here. We cannot go here for the same reasoning, right? Yeah. So then this has to be green. So this is green. This is not crate because blue would have to go through there. So this must be blue going through there. And this has to orthogonally connect either this way. Oh, this is blocked this way, so this must go that way. So then this has to connect here to be orthogonally connected to the rest of the unshaded cells. This could C5. We have 1. Okay, this can't be crate. So we have 1 here, 2 here. We could have 3 here. This can't be crate, obviously. So one of these two is crate. One of these, this can't be crate. So one of these two is crate, one of these two is crate. So that means it cannot go, it could touch here. And then go crate and crate. This is blue then. So non-crate. We have a crate here, we have a crate here. So this must be crate here, which means these are green. Okay. One of these is guaranteed to be a crate. So we have another crate in one of these. Or it could be here. Well, no. If the crate was here, we'd have to have crate here, and this green would not orthogonally connect. So this cannot be crate. So this is green. We can't have blue here, but that doesn't really tell us much. So one of those is crate. We have a crate in one of those. We could have a crate there. This could still see 7. So this sees 5. This... Can it see 5? Yeah, kind of. Can it have 5 crates? This has 1. No, so this must see 5. And this has 3 at most. So it must see 5. So it can see 4 at most there, so it must see this way. Blue. Okay, so these can't be yellow. Or these can't be crates. This is 2 that it sees. So 3 crates seen. 0, 4, 7, 2. Three, 6, so one of those 2, one of those is crate. We know we need 7 total here, so we need 3 more. This is green. It's either green here or green here. Hmm. This sees 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is green. Okay. Can this ever have a crate here? I think the answer is no, right? Because if we try to have a crate, where is this blue going to touch the edge? It will necessarily share an edge with one of these 3 cells here. So this must be a crate here. So that's 1, 2, 3, 4, 5. So these cannot have crates anymore because we have 6 in this rows and columns. We have a crate here, we have a crate here. Can we have crate here? Crate here. You can't have blue here because that would block this off. So I don't think either of these can be blue. I think these all have to be green. Right? If this is... So say we had blue here. That would force this to be crate. This green has to orthogonally connect to the rest of the green, but this blue must get to the edge. And that would be blocking each other. So that can't be blue. And it can't be crate. So this is green. That means blue has to go this way. If this is blue, Same problem, right? This is crate here, crate here. This blue blocks off the green from connecting with the other greens, and that doesn't work. So this is green here. That means it must go here. So this is blue. This must connect that way. It's blue. I think it has to be crate, crate here. Well, technically, this could be all blue, right? This can't be blue. If this is blue, this is crate, crate, and this is green, and then this green doesn't orthogonally connect. So this has to be green here. So there is a green here. And if this is blue, that would force red to be there, crate here, and then this green could never orthogonally. Well, technically it could. No, because the blue would block it off. So this can't be blue either, it's green. And I don't think we can have red, red here, because blue has to orthogonally connect. So this must be red, red here, which makes this green, green. These are green. This is 1, 2. We have to have a blue going to here, and we have to have a crate. So this must be blue going there. You cannot have green going here, because then this would be green would be blocked by blue this way, and blue going to the edge this way. So this is blue. Green has to orthogonally connect, so there it goes that way. One of these is red. If red is here, blue would have to go that way, which is possible. So we still don't know if this is crate. This is 5, so this must be green here to see 5. So therefore, this is blue here. We have to have 4 crates. This is 1. This can't be crate. That's 2, 3. Therefore, this must be crate here. This must orthogonally connect, so that's green there. We have 1, 2, 3, 4, 5 for this crate counter. One of these is a crate. We don't know which. Does this count crates? We have 1, 2, and 3. This would have to be 1, 2, or 3 also. They both cannot count unshaded cells, because this would be 7 that way. This would see more than 6 then. So one of them is counting crates, and we're not sure which. So if this is 7, counting crates, that's 3 guaranteed here, and then this must be 4. If this is counting crates, that's 3 here, and this must be 3. So this is 4 or 3, which makes this 3 or 4. Okay, well, great. That's not helpful there either. This sees, okay, so this, one of these is counting crates, we're not sure which. This sees 5, this sees 4, that sees 3, this sees 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This sees 2, this sees 2. This sees 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. This sees 4. This sees 5. This sees 5. This sees 2. We can't have create here. We could have create here. So that would make green green. Can we have create here? Can we have create here? Okay, 2 creates here. So 1, 2. This is still in flux. This sees 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This sees 4, 1, 2, 3, and one of these digits, one of those cells there. This sees 6, 1, 2, 3, 4, 5, 6. This sees 3, 1, 2, 3. This sees 0. That sees 2. This sees 6 with 1, 2, 3, 4, 5, 6. This sees 4. 1, 2, 3, 4. This sees 2, 1, 2. This either sees 4 crates. One thing is this can't be a crate here. If this is crate, the problem is this would also be a crate. And then this would be blocked off from the rest of the orthogonally connected regions. So this must be green. Since this is green, this can no longer have 4 crates here. So therefore, this can't be counting crates. It must be the actual amount. So this must be crates here. This sees 7 this way, total. So this must be unshaded cells. Therefore, we have crate here. Therefore, we must have 1 crate here too. Oof. So we have 2 crates here, which means there's 5 here. So this obviously can't be crate here. This must be crate here. This can't be crate, so therefore this is crate here. So that's done. This must orthogonally connect to be able to connect to the rest of the region. So this is green. This could be blue. We don't know. It's blue or it's... no, this has to orthogonally connect also. So this is green. We have 4 crates here. We need 1 more crate here because we have 2 here and we need a 3rd one. We need a crate here. Where can the crates be? So you could have blue potentially just going there. Right? Okay, so these cannot be crate. Oh. So one of these 2 is crate. Can this be a crate? So we have crate there. That forces all of this to be green. Blue would have to go here. And then green would be here. And red would have to be here. And then that would be stuck. So the answer is no. This cannot be crate. Which means crate has to be here. So this is crate, which means none of these can be crate. One of these 2 is crate, but the blue has to get to the edge. So this cannot be crate, which means this is crate here. This is green. Blue has to get to the edge, so this is blue. The green has to orthogonally connect, so this is green. This is green. This sees more than 4 cells. We have crate here, crate here, crate here, and crate here. That's 4. So this is green. And this should be the whole thing. This sees so let's do all the greens first. This sees 7 cells. This sees 5. This sees 5. This sees 2. This is an orange, so that's fine. This sees 2. This sees 4. This sees 5. 4 here. 2 cells here. 9 here. So that's 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. This sees 13, which is 12 there and 13th there. This sees 3. This sees 2. Crates. This has 7 crates. So 1, 2, 3, 4, 5, 6, 7. This sees 6. 1, 2, 3, 4, 5, 6. This sees 4. 1, 2, 3, 4. This sees 4. 1, 2, 3, 4. This sees 3. 1, 2, 3. This sees 2. None here and 2 in the column. This sees 6. 1, 2, 3, 4, 5, 6. This sees 2 just in the column. This sees 0. This sees 4. 1, 2, 3, 4. This sees 6. 1, 2, 3, 4, 5, 6. This sees 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This sees 2 here. And this sees 7 and 1, 2, 3, 4, 5, 6, 7. So let's make sure the oranges, we change them to green. And all the unshaded, all the green region connected orthogonally. The answer looks like yes. And is all the blue getting to the edge? And the answer is yes. So that's a solution. Unfortunately, there's no error check. There's no solution check on the Sudoku pad, but I prefer the Sudoku pad because I like the tools better than the PenPa. But the PenPa does have solution checking. Anyways, very cool. It's a nice little puzzle with the crates and the shaded cells. All working in tandem, but this is definitely very hard. Lots of deductions you have to make from this, and the logic is not necessarily easy, and on top of that, the execution is pretty difficult too. So, anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.